Hi, welcome to the Einstein-First project. My name is Warren Stannard, and this is a short video summary of a presentation that we did at UWA back in March. The aim of the project is to introduce modern physics into the physics curriculum. In chemistry and biology, of course, the latest discoveries is incorporated into the curriculum. Physics, for some reason, we're still teaching the majority of our physics from 17th century physics. Why? Well, it's our best understanding of the world. It's interesting, it's fun, and I believe it appeals to a much wider range of students. How are we going to do this? Well, by developing a body of resources, lessons, demonstrations, video clips, etc., trialling these at the schools, sharing our vision with high school teachers, exhibiting the ideas at the Gravity Discovery Centre. We hope to introduce a lot of the new modern physics. Some people think it's too difficult, but by creating simple analogies, simple models, I believe it can be quite accessible to students at high schools. Two pictures there. The first one is of photons or Nerf bullets. The second one is the warping in space-time, all by quite simple analogies. And physics is an inventing, it's a creative process. It's not about finding what the world is, it's about finding what the world is like. Therefore, we use analogies and models. Some people may say that there's no job in Einsteinian physics. Well, I think you'll agree that most of our modern technology is based on modern physics, electronics, medical instruments and so on. How many times have you heard someone say that I hated physics? It's boring, it's hard. And why is it that it seems that only boys, the majority, continue with physics at university? I'll just grab some pictures from the textbook, and you might notice the sort of the gender roles that's pushed in those pictures. So this is a fairly empty slide, this one, because this is for you to fill in the gaps. How do we make physics more appealing? Little slide that I often show in a physics class. If you receive a good education, what happens to these circles? Well, I believe that circle of what we don't know increases because we open up a whole new world. We start to discover things that we didn't even know existed. We start seeking questions rather than answers. So Einsteinian physics, I've broken it down into 4 sections. Special relativity, understanding time, space, energy, mass. Photoelectric effect, understanding photons and light. Quantum, understanding the microscopic world. And general relativity, understanding the larger universe. And so today I'm just going to have a really brief look at the first part, the special relativity, and coming up with some analogies and ideas to help in some of these fairly difficult concepts. It's all relative. Standing on travelators next to another person, who's moving? Sometimes it appears you're standing still, they're moving, and so on. So this is opening the concept of relativity, that all motion is relative. And things like distance is relative to the motion of the person measuring it. 2 people stepping out that red line, one says it's 6 steps, one says it's 10 steps. Who's right? And there's a little demonstration, a little animation showing someone looking out a window of a train into another train and people walking through the train, and it's very hard to tell who's moving and what what the speeds of each person is. Speed limits is something that students can understand quite well, that there seems to be limits to the speeds we can reach when falling, some sort of terminal velocity, which is less when a parachute opens. And the concept we're trying to teach here is that there's a universal speed limit called the speed of light. Here's a little experiment that students can perform just using their iPhone to calculate the terminal velocity of a balloon. And the idea is students get the idea that there is some limit to speeds that can be obtained. And if we look here at a couple cars trying to break lane speed records, seems to be some limit to how fast they can go. It doesn't seem to matter how much power and how much fuel they consume. It becomes harder and harder to break the record. And even at microscopic level, accelerating particles around in an accelerator, there seems to be some limit to the speeds that even very, very small particles can reach. And something very strange about this idea of the speed of light is that it cannot be surpassed even in a relative sense. So, if you're riding on a very fast bicycle and shining a torch out the front, the speed of the light beam is still exactly the same, it doesn't change. And that introduces some very strange and weird ideas. Anyhow, an important idea though is that as we put more and more energy into something to make it accelerate, it reaches this terminal velocity of the speed of light. So what happens to the energy? And Einstein came up with this realization that mass and energy are interchangeable, and the mass increases as more energy is put in. Just some references to some pop culture. This is the film Young Einstein many years ago. Now, but he had this little demonstration, or this little idea of speeding away from a clock, and if you're travelling at the same speed as the light is travelling, then you wouldn't observe any change in the hands on the clock, so time stands still. And films like Back to the Future introduce a whole lot of questions that students can start to think about. If Marty McFly can go back to the same place many times, then, well, is that possible? And what happens to the mass of the universe at that time if he went back hundreds and hundreds of times? And here's a little demonstration of things that appear simultaneous to one observer may not be the same to another. So perhaps need to explain that one a bit more. But there's some of the ideas that we can come up with trying to explain some difficult concepts. Another important idea from E equals mc squared is that a small amount of mass can produce a huge amount of energy. And another idea is if mass can be converted to energy, then most students realize now that mass is made up of atoms, which are indivisible particles. Therefore, perhaps energy is the same, that you can only have clumps of energy. You can't keep getting smaller and smaller amounts of energy, that it's clumpy, just like matter is. So that's about all there was for the first presentation, and the next one's going to be about photons and about what I've called Einstein's light, and we're going to look at the electromagnetic spectrum. And I think this will take up sort of the bulk of the new curriculum. There's just so many things we can talk about at that level. So the next meeting is going to be the 24th of April. Please come along if you can. And I think that's my last slide. Thank you.